Hi, I'm Professor David Farina. In today's lecture, we're going to talk about the Earth and its moon, in particular, the origin of Earth's moon. Let's get started. So, the moon and its origin for many years were a mystery, and there were three main ideas that were all unsuccessful. The first of these was the fission hypothesis. In other words, the Earth would have been going through its normal process of accretion and planet building, and then somehow the moon broke off from that main Earth body due to the rotation of the Earth in its early days. This is not a good method because we don't have any evidence that the Earth was rotating nearly quick enough for this to have occurred. The second is a capture hypothesis, where the moon somehow would have been another body from elsewhere, another planetesimal, and was captured by the Earth's gravity. This requires a very, very unlikely sequence of events to have occurred. Third, a condensation at the same time as the Earth's formation. This is probably also a problem because it has a different chemical composition than the Earth does, and if they were formed at the same time, then we would have expected them to have very similar composition. So the modern theory for the moon's origin has to do with a large impact of a Mars-sized body. So this protoplanet of Earth was differentiated already. Its core was already kind of an iron core, and sometime about 4 billion years ago or so, another body that was also forming independently collided with the Earth. And in this process, the Earth, being the bigger of the two, kind of won. And as it won, the Earth kind of absorbed the core of this Mars-sized body, making the Earth have a much bigger core than it really should. And this is important because it allows the Earth to this day to have a magnetic field, which we've talked about in previous videos, which is necessary to kind of keep Earth habitable because UV radiation is blocked by the magnetosphere. And other solar radiation, as well as interstellar cosmic rays, which are also damaging to life on Earth, are also being blocked by the magnetosphere. So the volatiles and other lighter materials were whipped up into a ring system after this impact, and that ring system eventually formed our moon. So this would require kind of a glancing impact to occur. It doesn't really work if you collide them directly. And the nice thing about this is that a glancing blow is actually much more likely than a direct impact. And so the impact hits, it's deflected, the material kind of gets pulled in some more. The heavier material goes towards the center, creating a much more dense Earth and a much less dense moon. So once again, the moon in bulk now. I've showed this in a previous video with the Earth's interior. We're going to focus on the moon now. So in the moon itself, we've got a solid inner core, approximately 240 kilometers in size. We've got a fluid outer core, which is very thin. We've got a molten inner mantle, and then we've got a solid outer mantle and a crust. So over the course of about 4 billion years or so, the moon has gone from its original state, which was multiple craters all over the place after it cooled off during that early stage of planet building, to then having the Mare formed about 3 billion years ago or so, until the modern times, when we've got some of these less frequent impactors hitting and kind of marking up the Mare over time. So thank you for watching today's video on the Earth and its moon and the origin of the Earth's moon. I hope you enjoyed this video, and if you did, please click that like button. And if you'd like to learn more, please hit the subscribe button. If you'd like to get a notification each time I make a video, click the bell at the bottom. And thanks for watching. Have a great rest of your day.